Alright, it's time for the Pythagorean Theorem video. This is probably the most famous theorem in all of mathematics, named after Pythagoras, who, arguably wasn't actually the first one to come up with this theorem. I think the mathematics behind the theorem actually predates him, but it's named after him, and so that's what we'll call it. But you can see Pythagoras depicted in Raphael's School of Athens here over on the left. Bunch of people around him listening to what he has to say, and he's not the only important person in this painting, right? This is on the back of my classroom for a reason, right? There are Plato, Aristotle right here. We have Euclid over here doing a mathematical construction with a compass. We have Michelangelo depicted up here, and a lot of other astronomers and pretty important thinkers of antiquity. So let's actually get right into it here, and we'll do a couple examples. The theorem basically makes a connection between the sides of a right triangle, and we can give these sides a little bit fancier names. The legs are adjacent to the 90-degree angle, and the hypotenuse, which is kind of a fancy way of saying the really stretched out, or the tense is where that comes from. The really tense side, which is the longest side in every right triangle. And the theorem basically says that if you take a and square it, add that to the square of b, then that's going to equal to the square of c. Alright, great. Alright, we probably know that or have learned that in the past, but let's go through a couple examples here, some easy, some more difficult, and see how we do. Number one. So we have, let's see, our hypotenuse is always important to identify that first. Right, in this case, the hypotenuse is 13. So where I see C, I'm going to put 13. And the other two letters don't matter. Doesn't matter one bit. You can interchange those all you want because of the commutativity of addition. So we're going to go 5 squared is 25, 13 squared is 169. We're going to subtract, we get 144. So x times x is 144. To get rid of that square, you do the inverse of it, which is a square root, and we're taking the principal root here only, so x is 12 feet. So x is 12 feet right in here. Alright, and that makes what we call Pythagorean triple, 5, 12, 13. Those are all integers that work inside the theorem. And it might be worth noting that in your geometry class you might go through proofs and stuff like that, and in my class we might do that as well, but there are tons of different proofs for this thing. A lot of them kind of revolve around like literally making a square out of this. So you're making a square that's 5 feet on each side. You're making a square over here that's 12 feet on each side, and then that's supposed to be the area of those two squares is supposed to be equal to the area of this 13 by 13 square. Right, so it's really kind of like a discussion about area, right? The area of this big square is equal to the sum of this area and the sum of this area, right? And even one of our former presidents, President Garfield, he actually came up with a very unique proof of the Pythagorean theorem, which I always thought was pretty neat. In any event, let's go to number 2. Here we're actually going to utilize not the Pythagorean theorem, believe it or not, we're going to utilize its converse. So THM is an abbreviation for theorem, and the converse is kind of like the opposite of the theorem, right? It's taking the if and then statements and kind of reversing them, right? And this one's basically saying it's going to ask a question: is this triangle a right triangle? And to answer that question, you have to basically throw these 3 sides into the Pythagorean theorem and ask a question: are these, do these 3 sides form a right triangle? Alright, so it's a question at this point because we don't know yet. And again, it's important to understand that the potential hypotenuse is letter C, and that needs to go off by itself. So we have 144 and 81. Does that equal 169? Well, definitely not. I mean, that's definitely like 225 or something like that. Whatever it is, it's not True, so we slash it. All right, so we slash that out and we make a statement. No, these sides do not form a right triangle. Not at all. All right. And in fact, if we wanted to get really specific, which we're not really going to do right now, but if we wanted to get really specific, this would actually form an acute triangle, because the c squared term is smaller than the other two, the sum of the other two squared. All right, number 3. Again, this is a converse question. We're trying to determine if this triangle is right. So we go and we plug it into our converse. So we go 8 radical 3 squared plus 8 squared. Does that equal 16 squared? And we see if it works. So here we go. 8 radical 3 squared, well, that's actually 8 squared radical 3 squared plus 64. Does that equal, what is that, 196, I think? No, that's not right. 256. That sounds better. All right, well, 8 squared is 64. Radical 3 squared is 3. It's just 3. So we're kind of simplifying here. You can use your calculator here if you want to. 64 times 3, that's 180, plus 12, 192, plus 64. Does that equal 256? And it looks like it does, yes. So that's a good thing. So yes, this is a right triangle. Great. So again, that's the converse, when you're kind of working backwards and you're asked to decide or figure out if that is a right triangle. Number 4. Number 4, we're going to find the area of triangle number 4. All right, and to do that, first thing I'm going to do is write down the formula for the area of a triangle. It's 1/2 base times height. All right, and we need to figure out what the base is. The base of this triangle is given. It's 12.4. Goes right here. All right, the height is not given. The height is always perpendicular to the base, and it's right there. We don't know that yet. So believe it or not, this is actually a Pythagorean Theorem question. To figure out h, we're going to use the Pythagorean Theorem. So here's what I'm going to do. I'm going to just deal with one of these triangles kind of by itself. I'm just going to look at the right-hand triangle. I'm going to make a little right triangle out of that. I'm going to extract it this way. All right, that's a right angle. This is h. This is 7. And this distance right here, this base, is actually half of 12.4. So we'll call that 6.2. All right, so here's a little mini Pythagorean Theorem question, right? We have h squared plus 6.2 squared equals 7 squared. So h squared plus, let's see, 6.2 squared. Let's go to our calculator. 6.2 squared. That's 38.44 equals 49. All right, and then we'll subtract. All right, we get h squared is, let's see, 49 minus 38.44. That'll give us 10.56. 10.56. And just like we did in previous example, we'll take the principal square root of that, just the positive root. So we're going to go square root of that answer. 3.2496. I'm going to bring it out to 4 digits just for precision's sake. So that's our height, right? That goes in our original formula where we see h. Excuse me. All right, so we're going to multiply that number times 1/2 times 12.4. And that'll give you your area, 20.14, we'll call it 148. 20.148. And we don't have any units, so we'll just say it's units squared. And that's it. To get that answer, of course, you kind of have to do a little side work here, Pythagorean theorem. All right, moving along, number 5. Number 5, again, we're looking to find the area. In the area formula, we need base and height. In this case, we don't have the base, but the height is 10. The height is right here. All right, so the base is going to be the entire length of this thing right down here. That's base. 5 only stands for, or only represents that distance. So what I'm going to do first is set up my little, I'm going to kind of extract this right triangle and just look at that one separately. So over here, you know, a little scratch work here. I'm going to put 10, 5, and I'll call that C for the hypotenuse. I'm just looking at the green triangle. So I'm going to go 10 squared plus 5 squared equals C squared. So that's 125 equals C squared. So we want to go and take the square root of 125. 11.1803. Do that again. 11.1803. That's the length of this right here. All right. And then I kind of want to think to myself, now I just wasted about 2 minutes, right? I actually didn't need to find that, right? I was just kind of like in the zone there. I found something I didn't actually need to find. What I actually need to find is down here, right? I need to figure out that distance, right? This 11.1803 is not wrong, but it doesn't matter. You know, I found that really kind of like for no reason at all. What I'm really looking for is this guy down here. Let's call that X. And that goes from here to here. All right, great. So now we have another little Pythagorean theorem. I'll put this one in purple. I'm looking at just the purple triangle. So I'll kind of draw that one off on its own. And it's a right triangle. This is 10, this is 12, and this is X. So I've got X squared plus 10 squared equals 12 squared. That's the theorem itself. X squared plus 100 equals 144. X squared equals 44. X equals the square root of 44, which is a decimal, so let's actually calculate that. And that's going to be 6.6332. 6.6332. All right. So that number goes right in here. What was it again? 6.6332. Great. So the whole base along the bottom, let me erase some of this stuff. The whole base along the bottom is 11.6332. It's if you go from here all the way over to here, you have to add those two. You have to add these two lengths together. So it's 11.6332, and that'll be your base that you'll put right here. So it's 1/2 times that times 10. So here we go. I'm going to go 0.5 times 11.6332 times 10. I get 58.166. And again, that's units squared. As you can see, sometimes you find more information than you need, which is okay. There's no damage and there's no harm done, but I could have definitely saved some time by having a little bit of a foresight and not doing any of this. It's not necessary. Last one. So here we have another area problem. We don't know the height or the base. So we need to find both of those. So the first thing I'm going to do is, and it's kind of like a three-step process, but the first thing I'm going to do is find the height. Alright, so I'm going to take, remember 12 only applies from here to here. So I'll take that triangle out and I'll look at it separately. 12, and this is the hypotenuse is 14, so it's h squared plus 12 squared equals 14 squared. And let's see, h squared 144, 196, h squared, let's see, that's 52, I think. Yeah, that sounds right. I'll check that just to make sure though. Sometimes I make mistakes. 196 minus 144. Let's go back. Yeah, that's good. And the square root of that's a little over 7. I'll guess it's about 7.2 or so. 7.2111. Alright, great. So that's our height. So I'm going to just literally put that right in here. I'll abbreviate it 7.2. Alright, next thing we need is this distance right here. We'll call that x. So I'm just looking at my right triangle. And there's the bell again, excuse me. Alright, as we look at this right hand triangle, right, you want to make sure that you're using values that, if you just found a value, right, and you have to use it again, which we do, you want to make sure that you're using, really sort of as close to perfect as you can get them. In other words, don't just use 7.2. Go a little bit more to the, maybe to the third or fourth digit, maybe even more. Your calculator actually will help you use, a lot of digits. It'll sort of just make, copy and paste. For example, if we set up our Pythagorean theorem, right, and we want to find this, 7.2111 squared, right? We kind of already found that, right? But if you didn't see that, right here, all you want to do is just immediately, once that previous answer is on your screen, just hit squared, and it'll kind of copy and paste that down to the next row. And of course, you're going to get 52. If you only use 7.2 squared, though, for example, 7.2 squared is not exactly 52. All right, and that discrepancy there, that 0.16 discrepancy it might seem, negligible to you, but it actually, if you carry that through in a couple steps to the very end product, you're going to get an answer that's significantly off. So anyway, we want to go over here. We want to go 52 equals 100. So x squared. So x squared is equal to, what is that, 48. So we need to take the square root of 48. The square root of 48 is just under 7. It's going to be, let's see, 7.9 something, I'd guess. Right, and yeah, 6.9 something. 6.9282. 6.9282. And that value goes right here, 6.9282. Alright, so now we're ready to kind of bring it all together. The whole base is 18.9282. I added 12 and 6.9282. And the height is, we want to use this one, it's a little bit more precise than just 7.2. So here we go. We'll bring it all together in a nice, neat answer. Area is 1/2 times 18.9282 times 7.2111. And we will just put that into our calculators and see what we get. So here we go. We want to go 0.5 times, let's see, 18.9282 times 7.2111. And we get 68.247. 68.247 units squared. Alright, so there's 20 minutes on Pythagorean Theorem. There's a lot more that I can do with it. We're going to next take a look in the next video at some Pythagorean triples, and we'll also talk a little bit more about when a triangle is acute, when is it obtuse, if it's not right, when is it those two things. So we'll get to those in subsequent videos.